Next, we will start by understanding the multi-layer perceptron. If you look at this diagram here, we could see that the neural network consists of the three layers. The first layer and the last layer are pretty straightforward. These are input and output layer. But the middle one is the hidden layer. So the input layer is responsible for receiving the inputs. These inputs can be loaded from an external source, such as a web service or a CSV file. There must always be one input layer in a neural network. There will always be an input and output layer. So we can have 0 or more hidden layers in a neural network. So here the circle represent neurons and the lines represent synapses. There is one input node for each attribute. That is, for each attribute, there is one neuron is created. In this case, for the age attribute, a neuron is created. Similarly, for income attribute, a neuron is created. So there is one input node for each attribute. So in this case, every neuron is connected to every other neuron in the network. The neurons within the same layer do not transfer information with each other. For example, the age value will be sent to your hidden layer. Income value, but it will not be like age will be sent to income. So neurons within the same layer do not transfer information with each other. The synapses are nothing but the connecting line between the input and the hidden layer. Next, the question is how many number of neurons should be there in the input layer? The number of neurons should be should be equivalent to the number of training data feature plus 1. Supposing you have 16 columns, 16 neurons plus 1 additional node should be there. This is for bias. Next, we will go ahead and take a look at what is hidden layer and what is the role of hidden layer. Now we will take a look at it. First of all, why it is called hidden layer? The hidden implies that they are not visible to the external systems and are private to the neural network. That is why it is called as a hidden layer. So now the next question is, what is the importance of hidden layers in neural networks? Do I need to have the hidden layer? So you can have 0 or more hidden layers in a neural network. It is optional. But the importance of the hidden layer is the neural networks are able to capture very complex relationship and achieve exciting performance in many tasks. For that purpose, the hidden layer is important. It needs to be included. Let's say that we wanted to train this neural network to predict whether a customer is profitable or not. For this, we assign two classes, class 0 and class 1. Here, the class 0 indicates the data point where the customer is non-profitable, and conversely, class 1 indicates that the customer is profitable. Okay, in a complex neural network, you'll be having more than one hidden layers. The output layer receives the input from the previous hidden layer. Supposing if you have two hidden layers, the output layer will receive the input from the second hidden layer. So you can have 0 or more hidden layers in a neural network. Usually each hidden layer contains the same number of neurons. Okay, the larger the number of hidden layers, supposing you have multiple hidden layers in a network, the longer it will take for the neural network to produce the output, and the more complex problems the neural network can solve by having multiple hidden layers. Okay, so the hidden layer, each neuron in the hidden layer values are calculated using the total summation of the input values multiplied by their corresponding assigned weights. And then this one will be stored in a variable called z. For example, age into W1 plus income into W3, age into W2. So age into W1 plus age into W2 plus income into W3 plus income into W4 plus bias. The output of this equation will get stored in a variable called z. And second task performed by each neuron in this hidden layer is it applies the activation function on the z. So in that case, what will 1 divided by 1 plus z to the power negative z? This is your sigmoid function. Hope you guys remember we discussed as part of the logistic regression what is sigmoid function. Sigmoid function is also called as an S curve. So that's the reason why I specified S here. This is nothing but sigmoid function. So in the case of hidden layer, each this neuron performs two steps. In step one, each neuron values are calculated using which means the z value is calculated using the total summation of the input node values multiplied by their assigned weights. And then what happens is the activation function will get applied on this z, and the activation function will be applied, and then the output of this hidden layer will serve as an input for your output layer neuron. Okay, similarly, the information or the output values fed to the next layer neuron as input till the output layer. So the activation functions used depend on the type of neural network. The activation functions will depend from one type of neural network, other type of neural network. In this case, the activation function is some sigmoid function. We have different types of activation functions are there, which we discussed earlier in the previous section. Next, the activation functions used depend on the type of neural network. That's what we discussed. And the next one is weight and bias. What is this weight and bias? The weights and bias. Okay, this is these are your weights and this is your bias. The weights and bias are known as parameters of a neuron. Why it is called parameters? Because the values for the weight and weights are and bias are estimated by the model. Hence, it is called as parameter. The weight is called as a parameter and bias is also called as a parameter. Okay, the next one is the single weight parameters represented as W and bias as B. Remember this, guys. And the next one is the output layer. The output layer is responsible for producing the final result. There must always be one output layer in a neural network. You need to have output layer. Okay, the output layer is the final layer in the neural network where the desired predictions are obtained. The output layer takes in the inputs which are passed in from the layers before it, and it performs the calculation via its neurons, and then the output is computed. In the case of output layer, even in the case of output layer, these two steps are carried out. So the output produced by the activation function of this hidden layer will be an input to this neuron. So this output value will be multiplied by the corresponding weights. Okay, similarly here. Okay, and then the activation function will get applied here. Okay, so that's what I mentioned. Z is fed to the activation function, which gives the output values of the neuron. The output layer has its own set of weights and biases that are applied before the final output is derived. So even the output layer, like input layer, the output layer also has its own set of weights and biases. This is weights, and look here, bias is there for even for the output layer. Like input layer, even for the output layer also we have the bias. Okay, the next question is how many neurons should be there in the output layer? Okay, the how many layers should be, how many neurons should be there in the output layer? Depends on the task that you are attempting work on. It depends on the task that you are attempting work. For example, if you wanted to work on a regression problem, then the output layer will have a single node in it. So whereas if you work with a classification problem, and if you want this network to produce the predicted class level, even in that case, if in the output layer, single node is enough. If you use a probabilistic activation function like softmax, then the output layer has one node per class label in your model. For example, in this case, the model has to assign the class label as a profitable or non-profitable. So in that case, single node is enough. But if you wanted to predict the probability, if you are using a probabilistic activation function like the softmax, then for each class, right? So if it is a profitable customer, what is the probability? And if it is a non-profitable customer, what is the profitability is going to be? So in that case, you need to have the two nodes should be there in your output layer. Okay, you understood, to summarize, you understood what is forward propagation. So far, we discussed about the forward propagation in simple terms, right? The forward propagation means we are moving in only one direction from input to hidden layer 2 or the output layer in a neural network. The forward propagation is the first step of training your neural network. Hope hope you are able to understand what exactly the forward propagation. Also, we discussed about the various layers and each layer's responsibility. Also, we discussed and how many number of neurons should be there in each layer. We discussed, and to compute the number of optimal number of neurons that needs to be used in the hidden layer, then in that we will discuss it in other section. Okay.